In this question here, you have to find the value of a if f such that the interval from a inclusive to infinity is mapped onto R for f of x equal to log e of x to the 4 is to have an inverse. So you have to figure out the value of a so that this has an inverse function. And for f of x equals log e x to the 4 to have an inverse, it must be a one-to-one function. And what you really need to do is have a look at the graph of that, and from there you can decide whether it's a one-to-one function or what you need to do to make it a one-to-one function, and then you can figure out what this value of a is going to be. And you can just type that into your calculator and you get something like this graph here, or you can do it manually, and you need to be able to do it by hand. For the calculator free exam, you never know what you're going to get. So the first thing to do is to really sketch the graph of y equals x to the 4, which I've done here. So it's a quartic, looks a bit like a parabola, a bit flatter at the bottom, and it passes through 0, 0. And then what I've done is set up a table of values, x equals -3, 0, and +3. And then subbing -3 into y equals x to the 4, you get 81 for y. When you sub 3 in, you also get 81. And when you sub 0 in, you get 0 for y. So when you sub any other positive x value into here, you're going to get a positive y value. And when you sub any other negative number into y equals x to the 4, you're going to get a positive number as well. So therefore all the x to the 4 values are positive except when x equals 0. So what that means is that the log e of x to the 4 values exist for all the x values except for x is equal to 0. That's because you can't have log to the base e or log to the base anything of 0. It's undefined. And that means that on the graph of log e of x to the 4, x equals 0 is going to be an asymptote, and x equals 0 is the y-axis. And so that's an asymptote, and then you end up with two log graphs like that on either side. And the reason for that is this. When you sub these x to the 4 values for positive x values, so all of these y values are going to be positive, so you're just getting log e of a positive number, so you get your basic log graph for those positive x values. And when you sub in the y values for x to the, or the x to the 4 values into this equation, all of these ones are positive as well for those negative x values. So for those negative x values, you're going to get positive y values, and you get a log graph going that way. And if you look at the point where x equals 3 and x to the 4 equals 81, and so the y value on this graph is equal to log e of 81, so I've written that in there. So that has the coordinates 3, comma, log e of 81. And when you sub in -3 into here, you get log e of 81 as well. So what that means is that this point here is just a mirror image of this point here. And that's going to happen for every single point on this curve. So you end up with a mirror image of this part of the graph on this side of the y-axis. So both of these parts make up the graph of y equals log e of x to the 4. However, it's not a one-to-one graph, because if you do the horizontal line test, it cuts in two places. So it means you have to get rid of one of these parts of the graph. And the way to tell which part to get rid of is to go back to this interval here, which is really the domain of this function. And you can see that on the right hand end it approaches infinity. Now this graph on the right hand end actually approaches x equals 0, whereas this one, if you move to the right, it actually approaches infinity for the x values. So that means that this is the part of the graph that you need to have, and so you need to get rid of this. Now looking at the interval from a inclusive to infinity, so a could be the number 0.1, and the graph would go from 0.1 inclusive to infinity. A could be the value 10, and in fact a could be any positive number, but it couldn't be the number 0, because the square bracket here means it would be included, but on this graph, x approaches the asymptote and never actually equals 0. And, and that's because you can't have log e of 0. So that means a is not equal to 0, but it can be any other positive number. So in other words, a is just going to be greater than 0. And that is the answer to this question.